Section 1.5 is all about angle pair relationships, and really it just builds on the last section where we learned how to identify and name angles. The first angle pair that we're going to talk about are complementary angles. Two angles are complementary if their measures add up to 90 degrees. They are said to be complements of each other. The next angle pair are supplementary angles. Two angles are supplementary if their measures add up to 180 degrees. So complementary is 90, supplementary is 180. Supplementary angles are said to be supplements of each other, just like we had the complements for complementary angles. So once again, complementary is 90, supplementary is 180. I've always thought of it as C comes before S in the alphabet, so 90 comes before 180. So complementary C, the 90 degrees, supplementary S, the 180. The next angle pair we'll talk about are called adjacent angles. Adjacent angles are two angles that share a common vertex and side. Sometimes I think that definition can get a little confusing. So the way I've always thought about it is that adjacent angles are angles that sit next to each other and share a side. So if you look at our diagram here, I've given you some adjacent angles that are either complementary or supplementary angle, and some non-adjacent ones that are complementary or supplementary. So if we look at the first diagram, we have adjacent angles that are complementary because they are forming a right angle, noted by that square box in the middle. So angle 1 plus angle 2 would equal 90 degrees. We have non-adjacent complementary angles. So if I put these two angles together, angle 3 and angle 4, they would form a 90-degree angle, but we would just know that because we would take the angle measures of angle 3 and angle 4, and they would add up to 90 degrees. Supplementary angles that are adjacent, they would, if you notice here, they are forming this straight line. A straight line is 180 degrees. So two angles that are sitting next to each other forming a straight line are said to be supplementary as well. So angle 5 and angle 6, if I added their measures, they would equal 180. Angles 7 and 8 are two non-adjacent supplementary angles. So again, if I take the measures of angle 7 and the measure of angle 8, add them together, I would get 180. For example 1, they want us to look at the figure and name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Before we do that, I want to talk about how we're going to name these angles. So if you look at this, there is only one angle present in this first picture. So therefore, we could name this angle that is marked by the 75 degrees by just angle H, since there's, again, only one angle sharing that vertex. But if you look at the second picture, there's actually three angles sharing vertex L. There's the 105 degree angle, the 15 degree angle, and also this big angle, angle JLM, that is also sharing vertex L. So we need to be careful about how we name them. So the first one, if we do complementary angles, we're going to look for two angles whose measures add up to 90 degrees. If I look at this, I have the 75 degrees and the 15 degrees. 75 plus 15 is 90. So if I wanted to write out the two angle pairs, I would write angle H, because again, I can name that first angle, angle H, since there's only one angle sharing the vertex H. And also angle KLJ, the small 15 degree angle, angle KLJ. Next, we'll do supplementary. I noticed that 75 plus 105 is 180, which is the definition of supplementary angles. So again, I can name that angle H, and then I'll name the 105 degree angle, angle MLK. For the adjacent angles, remember, I'm going to look for two angles that are sitting next to each other and sharing a side, which I see that happens in our second angle over here. So the two angles I would name angle JLK, that's the smaller 15 degree angle, and then angle MLK. And something I do want to note here, I could name angle MLK, angle KLM. Remember, it doesn't matter what order you put them in as long as the vertex is the middle letter. Example number 2, part A. Given that angle 1 is a complement of angle 2 and the measure of angle 1 is equal to 17 degrees, find the measure of angle 2. So knowing that complementary angles add up to 90 degrees, in order to find the measure of angle 2, I would just take 90 degrees minus the 17 degrees that I was given for the measure of angle 1. 90 minus 17 is 73. So the measure of angle 2 is 73 degrees. On to part B. Given that angle 3 is a supplement of angle 4 and the measure of angle 3 is 119 degrees, find the measure of angle 4. So similar to the last one, I know I'm going to have to subtract, but this time we're told that they're supplements of each other. Supplementary angles add up to 180 degrees. So this time I'm going to find the measure of angle 4 by taking 180 rather than 90 like the last time, minus the 119. 180 minus 119 is 61 degrees. And I realize I forgot to put the degree symbol up here. Always label your answers. Example 3, two roads intersect to form supplementary angles, angle XYW and angle WYZ. Find the measure of angle XYW and the measure of angle WYZ. So if you look at our diagram, we see the two angles, WYX and WYZ, and we're told that the first angle is 2x plus 14 and the second angle is 4x minus 20. So knowing that they're supplementary, I know if I add the two angle measures together, I will get 180. Also notice that these two angles are forming the straight line. So a straight line has 180 degrees, which further gives us evidence that the two angles are supplementary. So with that being said, let's take the two angles, 2x plus 14, and I know if I add that to the 4x minus 20, I will end up getting 180 degrees. So it's a lot like when we did all the segment addition stuff earlier in the chapter, except now we're just dealing with angles. So first we'll combine like terms. 2x and 4x is 6x. 14 and negative 20 is negative 6. And then we'll add 6 to both sides. So again, this is just some basic algebra. Divide both sides by 6. And x equals 31. So what it wanted us to find was the measure of angle XYW. So now that we know that x equals 31, I'm going to substitute that into my expression. So we'll take 2 times 31 plus 14. 2 times 31 is 62. 62 plus 14 is 76. So the measure of angle XYW is 76 degrees. For the measure of angle WYZ, we can do a shortcut. Since we know the two angles are supplementary, we can simply just take 180 minus our previous answer of 76 to get our final answer. So the measure of angle WYZ would be 104. We can verify that by taking our x equals 31, substituting it into our expression for the second angle, 4x minus 20, and we would still get 104. There are two more angle pairs that we need to explore. The first one, number 4, two adjacent angles are a linear pair if their non-common sides are opposite rays. I really think this definition is really confusing. The way I think about linear pairs is that they form a straight line. If you look at the root word, and we've talked about this before, the root word of linear is line, and a linear pair forms a straight line. If a linear pair are forming a straight line, and a straight line is 180 degrees, which we kind of talked about previously when we were talking about supplementary lines, if two angles are forming a straight line, those two angles would also be called supplementary. So here again, a linear pair are two angles. Since it's pair, it's two angles that form a straight line, and therefore they would be supplementary. Next, let's talk about two angles are vertical angles if their sides form two pairs of opposite rays. Out of all of these definitions that I've said are confusing, I think this one takes the cake. The way I think about vertical angles is what I stated here next. Vertical angles are formed by two straight intersecting lines, and they sit across from each other. So if we look down at the diagram that I gave, I have two intersecting lines. Angles 3 and angle 6 sit across from each other, angles 4 and 5 sit across from each other. So therefore, angle 3 would be a vertical angle with angle 6, and angle 4 would be a vertical angle with angle 5. Moving on to example 4, identify all of the linear pairs and all of the vertical angles in the figure. So let's first do linear pairs. So in this example, we're going to be looking for two angles, just two angles, that are forming a straight line. So when I look at this diagram, I see angle 1 and angle 2 are forming this straight line, and angle 2 and angle 3 forming this straight line. I've had kids in the past think that angles 3, 4, and 5 would be linear pairs because they're forming this straight line, but again, it's a linear pair. Pair means two. So therefore, we're only looking for two angles that form straight lines. So again, we're going to do angle 1 and angle 2, and angle 2 and angle 3. Moving on to vertical angles. So remember from the last slide, vertical angles are formed by the same two intersecting straight lines. So if I look at these, I have this line intersecting with this line. So again, this line right here with this line right here. And vertical angles sit across from each other. So I have angle 1 sitting across from angle 3. And I would not have angle 2 be a vertical angle with angles 4 and 5. They have to be an angle pair as well. So we're not looking for, one angle that is a vertical angle with two other angles combined. We're only looking for one angle, vertical angle with another angle, just one other angle. So the only vertical angles we have in here are angle 1 and angle 3. In the past, I've had kids think that angle 2 is a vertical angle with either angle 4 or angle 5 because their claim was that angle 2 sat across from angle 4 or that angle 2 sat across from angle 5. However, you need to remember that vertical angles are formed by the same two intersecting lines. Angle 2 and angle 4 are not formed by the same two intersecting lines, and neither are angle 2 or angle 5. Our last example, number 5. Two angles form a linear pair. The measure of one angle is 3 times the measure of the other angle. Find the measure of each angle. And that's all they give us. This problem seems so blank that we're not even sure where to start. So let's chunk it up. Let's look at it in pieces. Two angles form a linear pair. Remember, a linear pair forms a straight line, and a straight line equals 180 degrees. Therefore, these two angles are supplementary. So I have that going for me. Then I have the measure of one angle is 3 times the measure of the other angle. So let's start off by saying, well, what if the first angle, let's just call that x. So the second angle we know is 3 times the measure of that first angle. So I would characterize that with 3x. So again, these two angles are a linear pair, which we said are supplementary. So if I take our first angle, x, add it to 3x, our second angle, they would equal 180 since linear pairs are supplementary. X plus 3x is 4x equals 180. Divide both sides by 4 and you end up with 45. So remember, our first angle was x. So the measure of the first angle would be 45 degrees. And you know that the second angle is 3 times that, or you could just take 180 minus the 45. So our second angle would be 135 degrees. As always, write down any questions that you might have that you can bring to class so that we can cover those and clarify those before we move on and do the assignment over this section. We'll see you then.